All right, guys. Focus in. So what we talked about yesterday are types of transformations with our parent functions. Almost.
No, we have homework today. Okay, good. Got it. Yeah. Wait, where is this? What page?
So we filled this in
Oh, yeah, we already filled it.
yesterday.
I'm struggling with this. Why is it That's gonna be unique aneurysm. You almost had it in the exact same spot. That's Look at that, guys. Look how impressive that is.
That is actually pretty.
Wow. Look.
So we have linear equations, which are given to us by f of x equals a times x minus h plus k. Our quadratic f of x equals a times x minus h squared plus k. An absolute value. F of x equals a times the absolute value of x minus h plus k. 1, 2, 3. So we had these three equations yesterday. Now, our values of h, k, and a. H is our horizontal translation. It is our left or right. So how far we move the function left or right. K is our vertical translation. So how far we move it right. Or sorry, not right. That'd be up or down. Up or down. And then our A, if negative, it's a reflection across the x-axis. So these are the main three transformations we talked about yesterday. Now the one thing we're going to add today is our vertical stretch and shrink. And how we tell if there's a vertical stretch or shrink, or how vertical stretch or shrink is applied to a function, is also coming from A. So if A is greater than 1, then it is a vertical stretch. If A is between 0 and 1, it is a vertical shrink. So if A is greater than 1, it's a vertical stretch. If A is between 0 and 1, it's a vertical shrink. Now, if the value of A is negative, then it's a reflection across the x-axis. Questions on this here so far? Okay.
We do have
Mm-hmm.
You still mad about that? No? You still mad about that? No, Everett. You still butthurt? You're the one who complaining you have work till 10. What? I want to show that.
All right, guys, let's focus in. All right. So, when the factor, Another way to transform a graph of a function is to multiply all the y coordinates by the same factor. When the factor is greater than 1, it's a vertical stretch. When the factor is between 0 and 1, it's a vertical shrink. Now, if we look at this graphically, we'll use the absolute value of x. So if we have a number in front of it other than 1, let's say 3, it's going to be a vertical stretch. And when it's a vertical stretch, it's going to increase along the x or the y-axis faster. So it's going to go up quicker. Now, if it's a vertical shrink, blue is the original.
Oh, wait. No, it's going up more steeply.
Yes. So the blue is the original. The one in red is the vertical stretch. It's increasing faster. It's going up quicker.
Yeah.
The one in black is a vertical shrink. It's increasing slower along the line. It's spread out. It's stretched. So vertical stretch increases faster. Vertical shrink increases slower. Now, if we look at the first equation here, hey, g of x is equal to 2 times the absolute value of x. Well, this parent function is absolute value. Absolute 2 times the absolute value of x. Now, for this one here, we do not have a value of h. We do not have a value of k. There's not a number in either one of those two places, guys. So since there's no value for h and k, there is no movement left, right, up, or down. But the value of a in this case is 2. So that tells us that we have a vertical stretch of 2. Because whenever the value of a is greater than 1, it's a stretch. If the value of a is between 0 and 1, it is a shrink. Also, if the number is negative, the negative part is a reflection, the number is the stretch or shrink. Those two are separate from each other. Any question on A before we look at B? So B, h of x is equal to 1/2 x squared. Well, its parent function is a quadratic because of the square. Now I'm going to write the quadratic general equation right below it. Now, this here, again, there's no translation, left, right, up, down. But our value of a is what? 1/2. Guys, let's focus in. So the value of a is 1/2. Is that between 0 and 1 or greater than 1? It's between 0 and 1, which means this is a vertical shrink of, guys,
Hey guys, pay attention.
guys, let's focus in here. Vertical shrink of 1/2. And that's it.
Let me have this.
Any questions on B before we move on to numbers 5?
So it's 5, 6, and 7 done the same way as this.
Yes. All right, guys, let's look at number 5. G of x equals 3x. Now, the parent function would be linear. Now, the general equation for linear is a times x minus h plus k. Well, again, there's no h value or k value, so it's not moving left, right, up, down, but we do have a value of a. And the value for a is 3. Is that greater than 1 or between 0 and 1? It would be a vertical stretch of 3.
How do you know if it's vertical or
If
horizontal?
it's above zero.
Horizontal will be inside the parentheses. So horizontal stretch or shrink, and we'll see this here with some of the stuff that we'll do tomorrow or Monday, part of 1.3, where that b is in front of the x, inside the parentheses, that's where the horizontal stretch or shrink is going to be. You know, horizontal stretch or shrink, horizontal translations are going to be inside the parentheses or absolute values. Vertical is in front of outside. Now the next one is quadratic,
Because it has that square.
because it has the square. So we have 3/2 x squared. Now we have a 3/2 in place of a, so we're talking about vertical stretch or shrink. Now since it is a fraction, it means it has to be vertical shrink, right?
Not really. Not
Is 3.5 less than 1?
seriously? Well, that's not 3.5. It's 1.5.
So this here is indeed more than 1, so it is a vertical.
Correct. You would have got that wrong. No, I would have gotten that one right.
3/2. So just because it's a fraction doesn't mean it's always going to be a shrink. We have to see, is the fraction between 0 and 1 or greater than 1? Normally with fractions, if the top of the fraction, the numerator, is bigger than the denominator, the bottom of the fraction, it's bigger than 1. Questions on number 6? We're ready for number 7.
7 would be
It would be absolute value, and it would indeed be a vertical shrink.
we're learning.
And the reason it's a vertical shrink is because it's between 0 and 1.
Is this what the homework assignment is?
Yes.
It's not like he's going to give us more homework.
Mr. McClendon, you're not that teacher, right? You're not going to be like, oh,
No.
No, I don't see
I could think of my miserable.
No, that's Mr.
Any questions on these 3 here? All right, guys. Let's focus in here, guys. Now, the last few that we're going to do are these here. Now, now the transformations do not have to happen one at a time. We can have more than one transformation being applied to a function. So if we look at this here, f of x is equal to 2 times the absolute value of x plus 1. Well, its family is absolute value. All right, guys. Right. The parent function. So it's absolute value, which means all other absolute values are part of that family of functions.
So why don't they just say identify the parent value?
So identify the function, the family that which f belongs to. So it's the absolute value. So the parent function for the absolute value is just the absolute value of x. All the others are other iterations of it. Now looking at this here, we do have 2 values. 2 of our 3, a, h, and k, are being used. K is our up and down. And what is the value for k in this here? It's 1. Now we need to determine, are we moving up 1 or down 1? Up 1, because the 1 is positive. Now we do not have a value for h, so there is no movement left or right. But we do have a value for a, and the value for a is 2. Now since the value of a is greater than 1, it tells us it is a vertical stretch of 2. And those are the only 2 transformations being applied to this here. Questions on this so far? We ready for the next one? Okay. Guys. Guys, let's focus in. Mm-hmm. Let's look at this one here. Our next function, g of x, is equal to 1/4 of x minus 3 squared. Now the family it belongs to is quadratic, because it has the square. Now this one, just like the last one, we do have 2 transformations being applied to it. The one we do not have applied to it is our value of k, the up or down. So there is no up or down movement. But we do have a movement left or right. And the value of h is 3. Now would it be 3 units to the right or 3 units to the left? It is indeed to the right. Because our left and right is the opposite of what we think. Because since it's x minus 3, it does look like we would be going left 3, but it's actually right 3.
So positives go right. And left.
Left. Yes. Because really for this here, the value of h is positive 3. Because our x's line up, the minus line up, so h is just 3. If it had been x plus 3, then technically the value of h is negative 3. But minus goes right, plus goes left when we're inside those parentheses. Now the other thing we have is our value of a is matching up to the 1/4. Yep, 1/4. So that tells us we have a vertical shrink of 1/4. Do we have a reflection? No. For us to have a reflection, A would have to be what?
A would have to be
Negative. The negative. If it was negative 1/4, then it would be a reflection. The number there is not as important if it's 1/4, 2, 3.
just
It's,
negative or positive.
if it's negative, it's a reflection across the x. The number itself tells us stretch or shrink, vertical stretch or shrink. Its sign tells us if it's a reflection or not. Because if it's positive, there's no reflection. If it's negative, there is a reflection. So if we look at this one here, g of x is equal to negative absolute value of x plus 5 minus 3. Well, that tells us it's an absolute value function. And this one here, we actually have 3 transformations. What is one of them?
You're going to have, oh wait, why is it just a straight negative for the A?
So let's go there first.
So that's a reflection.
So the negative where A is tells us that we have a reflection across the x-axis. Because again, negative where that A is negative, and because it's negative, it's a reflection across the x-axis. Now the number there is 1. Since this number is 1, there is no vertical stretch or vertical shrink. The negative is purely with the reflection. What's the next one we have?
You've got a positive 5.
We have the plus 5, the x plus 5 inside.
But it's a negative h, so it's odd.
Yes.
Yeah.
So we have x plus 5. The 5 is telling us we're moving 5 units to the left.
And then the last one.
So h gives us left and right, and our minus 3 is lining up with k, yes?
It
And
would be less 3.
so k is which one?
No, it would be up.
Up and down.
It would be up.
K is up and down. H is left and right. A tells us reflection if it's negative. Or if there's a number there besides 1, it's a stretch or shrink.
So when it goes up or down, is it like how it is? Like
It is exactly how it is. So since it's minus 3, it would be down 3.
So
So-
it's not flipped like.
So anything inside, except for reflection, but pretty much most of our stuff that we do inside the parentheses are absolute values, opposite. So when we talk about
so instead of
left 5, if it's minus 5, it's right 5.
then try to go. Never.
So anything outside the parentheses
So we're gonna have a
exactly as it should.
Yes, anything outside the parentheses is exactly as it shows. So if we look at this here, we have plus 4.
So that'd be plus 4.
So the plus 4 is a part of our k, because our a times x minus h squared plus k. Well, k is telling us we're either moving up or down. Now, the amount we're moving is 4. Now, is it 4 units up or 4 units down?
4 units up.
Because up and down is exactly as it looks. Since plus 4, up 4.
Is this quadratic?
This would be a quadratic, yes.
Every group built like a
All right, guys, let's focus in. Guys, the negative 0.25 is our other spot. Now, there's actually 2 transformations taking place there. The negative and the 0.25. The 0.25 is our vertical stretch or shrink.
It shrinks and it's a reflection.
Yes. So it would be a vertical shrink of 0.25. Now, the negative tells us it's a reflection across the x-axis. So the negative and the 0.25 are 2 separate transformations. The negative is the reflection. The 0.25 is our vertical stretch or shrink. So we keep those 2 separate. Does that make sense? Questions on any of this here? Questions on anything we've done so far? Be ready for the next problem.
Oh, that's what we
3 through 5, 9 through 15 odd, 19 through 25 odd, 27, 28, and 31.
I saw the odds, so it's like 3 through 5. And then I was like, odds to like
9, 11, 13, 15, 17. Dude, hey, dude, I thought we were past that. You're such a jerk.
yeah.
So 9 through 15 and 19 through 25 are the only ones you're doing odd on. So you'll do 3 through 5 all, 9 through 15 odd, 19 through 25 odd, 27, 28, 31. Nice.
Brett,